There are a few ways to get at this type of problem in number 19. What I'm thinking is we could do a couple things. We could cross multiply, which actually works out nice because this is a proportion and good things will happen when we're done. Or we could, multiply first both sides by 4, then both sides by 3, which ultimately means multiplying both sides by 12 to gobble up the denominator. The results will be the same. I personally think I like cross multiplying better, so I'm going to save that method for last. If we had to multiply both sides by a number, 12 would be the number because 12 can, in a sense, absorb 3 and 4. And so when I multiply the left side by 12, I can cross cancel and I get 1 here and 4 here. So this side is 4 times 7 plus 6. I'm sorry, z plus 6. And this side will be 4 goes into 12 3 times 2z. Notice if I had cross multiplied, right? If I took these guys and multiplied it together, I get this. And if I took these guys and multiplied it together, I get that. So it's the same difference. All right, with that in mind, we're going to distribute through. We get 4z plus 24 is equal to 6z. I'm going to choose this side for my z's and this side for my constants. So I'm going to add the opposite. I'm going to add a negative 4z to both sides to get rid of the z terms on that side. 24 is equal to 2z, and clearly z is equal to 12. Our check, let me use a thinner pencil, is our check will be simply putting 12 in for everywhere we had z in the original equation, and then so I've got 2 times 12 here over 4. And we'll see 12 plus 6 is 18 over 3, which gives me 6. And then on the right side, we've got 24 divided by 4 is 6. And we see that we are comfortable. Our answer that z is equal to 12 is correct. In problem number 20, we are going to find the perimeter or solve for x so that the perimeters of both of these triangles are equivalent. Perimeter, as we remember, is the sum of all sides, so I'm going to add up all of these sides and set it equal to the sum of all of these sides. Okay, let's make that a little smaller, and now we can write this equation, which I didn't have enough space to put on one line, so that's not the best practice, but I'm going to simplify each side and I'll be able to put everything on one line. Simplifying each side means joining like terms together, so on the left side of this equation, I can join that negative 5, this positive 5, that's going to give me a 0, so this negative 5, this positive 5 gives me a 0, and then I have negative 4, and then I have 2 x's, so I'll be left with 2x minus 4. And on the right side, I can join the 16 and the 10 to give myself I could join the 16, 10, and the negative 10, in fact, to give myself a 16 plus x. And so now this is pretty simple. I can fit everything on one line, which is what I should probably do. And then I'm going to decide that my x terms are here, so I'm going to get rid of x on both sides. X minus 4 is equal to 16. Add 4 to both sides. I get that x has to be equal to 20. And of course, I can plug it back in and check to make sure that it all works out, or plug it back into my original equation to make sure everything works out. I worked with one of your classmates on this problem, and I didn't find the wording super easy to understand in number 21. But what the gist of it is that you've got one company whose production cost is going to be given as $8,000, and then added onto that production cost is $5 per glove. And then the other company has $10,000 production costs, monthly production costs, and then an added $3 per glove. And so we're going to find the time when they're both the same, when both of the companies have the same, for what value of the number of gloves prepared or produced. So the equation basically looks like this. 8,000 plus 5x should equal to 10,000. Here we go, extra 0, plus 3x. And this is one company, ABC, I believe, and this is XYZ company. And when we find the value that satisfies this equation, we'll know that at that number of glove production, they actually have exactly the same cost. We'll do exactly what we usually do. We'll choose a side for our x, choose a side for our constants, get rid of the 3x on both sides, like a that, get rid of that. We're left with 2x is equal to, well, 8,000 plus 2x is equal to 10,000. And then at this point, what we need to do is move our constants over. I'm going to just move over here. And our answer is, well, our next step is that we get 2x is equal to 2,000. And then x will be equal to 1,000. And that's our answer. After 1,000 gloves, both companies, or at 1,000 gloves, both companies' monthly costs are the same. In number 22, we're going to evaluate some expressions and they happen to have absolute value. Here's my hint to you. You've got to do everything within the absolute value symbol before you take the absolute value. So let's see how that works out in this example. I'm going to replace each of the variables. So I get 3 times negative 4 minus 2, all of that in absolute value, plus 2 times 7. So when I do this problem, I've got to do what's in the absolute value symbol first. Negative 12 minus 2, still in the absolute value symbol. 2 times 7, should have just wrote 14 there. And then when I continue on, I get the absolute value of negative 14 plus 14. Now I take the absolute value of negative 14 and I write that as 14 plus 14. And my answer is not 0, but 28. So here in number 23, I've rewritten the problem, and then I've also rewritten it with the values for y and z. And again, within the absolute value symbol, I've got to do the math first. So I get negative 28 plus a negative 18. I'm going to take the absolute value of that after I've finished it. 7 times a negative 9 is going to give me a negative 63. And then I end up with the absolute value of negative 46 plus 63. Remember, minus, keep, change, so that became a positive 63. Get it? Down at the bottom. All right, so this is just 46 because the absolute value of negative 46 is positive 46 plus 63. And when I add those together, I get 109. I really like number 24. I would never give it to you as a multiple choice. Clearly, all you need to do, like I said before, if you're taking a standardized test and you're given something like this, plug in the answer choices and see which ones work. But since we're not doing it that way, we're going to use our algebra skills, give ourselves some more space, and let's answer this. So the absolute value of 6m minus 3 is equal to 9. Recall that, thought bubble, when the absolute value of x was equal to 4, there was no problem with you guys saying, well, x equals 4 or x equals negative 4, because when I put the absolute value on it, it's going to be positive. That's the same thing here. All of this junk is either positive 9 or negative 9. And because we've got those two choices, absolute value breeds two equations. 6m minus 3 equals positive 9, or 6m minus 3 equals negative 9. So we've got two things we need to do, and that's how we get those two answers oftentimes. 6m is equal to, get rid of that, 9 plus 3 is going to give me 12. M is therefore equal to 2. You know, if I divide both sides by 6. Over here, I'm going to add 3 to both sides. That goes away. 6m is equal to, this time, a negative 6, so m could equal negative 1. So let's go back. I've got m is equal to 2 or negative 1. Let's mentally put it in here and see what happens. 6 times 2 is 12, minus 3 does give me 9, makes sense, but let's try negative 1. Negative 1 times 6 gives me negative 6, minus 3 gives me a negative 9, but I'm taking the absolute value, and I get a positive 9. So clearly G is our answer. For number 25, we're going to write an absolute value equation, because usually whenever we have a plus or minus situation like we do here, it implies that we've got not just any equation, but an absolute value equation. So talking about brewing coffee, we should have it at 200 degrees Fahrenheit, plus or minus 5 degrees. So that means the temperature difference from 200 degrees, right? Temperature difference from 200 degrees must equal 5. The temperature difference from 200 degrees must equal 5. So we can go up by 5 or down by 5. So we get the absolute value of x minus 200 is equal to 5. And then we can solve it like we did the last one. This thing in here is either positive or negative 5. And we need to write the two equations that reflect that. So here we have it. I'm going to add 200 to both sides. And I know you guys already know the answer to this, but it's good to go through the process. So one value could be up to 205. It's good to go through the process to make sure that your skills at creating equations matches your knowledge. So we've got 195 here as the two temperatures that we could have. So from 195 to 205 degrees. All right, guys, so sorry we had to do this in two parts, but I hope this was helpful. Please review. Feel free to send me an email so I could possibly help you. I can't guarantee getting back to you in the same time of day, but I'll try my best to get back to you. Take it easy and have a good one.